Welcome again. In the previous lecture I have completed the unit 2. Now in this lecture I am going to discuss the unit 3. In unit 3 the contents are basically transistors, that is unipolar transistors and bipolar junction transistor, that is FETs and BJT. First of all we will discuss the bipolar junction transistor. First time in 1947, 3 scientists in Bell laboratories in USA, they invented bipolar junction transistor, that is 3 layer bipolar junction transistor. These are the 3 scientists, and the leader of 3 scientists was the William Shockley. So that we can say that Shockley and his 2 colleagues invented bipolar junction transistor in 23rd December 1947 in Bell Laboratories USA, and this is the figure of that transistor which was used in first time in Bell Laboratories. Now construction construction of bipolar junction transistor are shown here: NPN transistor and PNP transistor. This is the 3 layer semiconductor and 2 junction semiconductor bipolar junction transistor. The question arises that why it is called bipolar? It is called bipolar because the conduction in this transistor exists due to the both type of charge carrier, that is majority charge carrier as well as minority charge carrier. So that it is called bipolar junction transistor. On the other hand, the next device will be the FET, and that device will be the unipolar junction transistor, that is the working in FET exists due to the only majority charge carrier. On the other hand, here the working exists due to the both type of charge carrier. So this is the construction of NPN and PNP transistor, and the size and doping of these 3 layer are different. Why these 3 layer size and doping are different, I will discuss it later. First of all, symbol. This is the symbol of NPN and PNP transistor. We know that in case of diode the direction is from p type to n type. This means the current flows in case of PN junction diode is from p type to n type. This means the direction of conventional arrow is taken from p type to n type. So we can easily detect that in this NPN transistor the direction is from base to emitter. This means base must be the p type and n must be the n type. This means that this is the NPN transistor. On the other hand, the arrow is in this direction. This means emitter must be the p type and base must be the n type. So that the arrow is in this direction from emitter to the base. So we can easily identify that which type of transistor is this by identifying the direction of arrow. We can easily identify, because the direction of arrow is always from p type to n type. This means we can easily identify. Now these are the 3 layers. Okay guys, in n type collector and n type emitter, because p type is sandwiched in between 2 n type. So n type collector and n type emitter, majority charge carriers are electron. On the other hand, in p type base the majority charge carriers are holes. Now what will be the doping of these 3 layers and what will be the size of these 3 layers, I will discuss in the next slide. So to discuss the size and doping, first of all we need to know that what is the role, what is the function of these 3 terminals. Now first of all, emitter. Since words is emitter, this means this layer or this terminal will emit the majority charge carrier. Since emitter has to emit the majority charge carrier, so that the doping of the emitter layer should be maximum amongst the 3 layer, so that we can say that emitter is the heavily doped layer. Emitter is the heavily doped layer or heavy doped. Now what about the size? Size of emitter is kept moderate, that is the size of emitter is less than that of collector. Now, on the other hand, what about the base? The function of base is to bypass the majority charge carrier to the collector. Bypass the majority charge carrier. This means bypass the maximum majority charge carrier to the collector. The base layer will bypass the maximum charge carrier. For this, the doping of the base layer should be least. Why should be least? Because the base layer has majority charge carrier in opposite nature of the emitter. This means the electrons, those electrons which have emit the emitter, then base will be recombined with those electrons. This means the base has to bypass the maximum majority charge carrier, so that this means the recombination between the majority carriers of emitter and majority carrier of base should be minimum. This means the base layer must be least doped, so that the base is the least doped, and size also should be the thin. Why thin? Because so that the majority charge carrier can easily bypass into the collector. Now, what about the collector? Collector will collect the majority charge carrier. Collector will collect the majority charge carrier, so that the doping of the collector should be moderate. Why it should be moderate? Because the collector has the same nature of majority charge carrier, which majority charge carrier has to collect, so that the collector doping should be moderate, so that it can easily collect the majority charge carrier. Now, the size of the collector is kept larger than that of emitter. Why larger than that of emitter? Because the collector layer has to dissipate more power. Since collector has to dissipate more power, so that for heat sinking the size of the collector is greater than that of emitter. This means in order of size, that is the size of the collector layer is greater than that of emitter, and emitter size is greater than that of base, that is base is the least in size. On the other hand, the doping of the emitter layer is greater than that of collector, and the doping of collector layer is greater than that of base. This means base is least doped. Now, connection or configuration of transistor. There are three types of connection is possible in case of transistor, because there are three terminals. In one terminals we are giving the input, and in another terminal we are taking the output, and the third terminal is taken as common with respect to input as well as with respect to output. So that terminal is called common. So that there are three terminals, one is the input, another one is the output, and third one is the common. So that there are three types of connection or configuration are there: common base, common emitter, and common terminal. Now, in this figure you can see that here base is common with respect to input and as well as with respect to the output, so that it is called common base. Basically, base layer is taken as ground, or you can say reference voltage, so that we are giving the input at the emitter terminal with respect to the base, so that, and we are taking the output from the collector terminal with respect to the base. So, base is common with respect to input as well as output. Here emitter is the input terminal, collector is the output terminal, and base is the reference terminal or common terminal or grounded terminal. On the other hand, in case of common emitter, emitter is taken as common for input as well as output. Here base is the input terminal, collector is the output terminal, and emitter is the common terminal or grounded terminal. Now, on the other hand, in case of common collector, here collector is taken as common, with respect to input as well as with respect to output. Here base is the input terminal, emitter is the output terminal, and collector is the common for input as well as output, so that it is called the common collector terminal. Now, common base and common emitter configuration are used as an amplifier. On the other hand, common collector is not used as an amplifier, because the voltage gain of common collector terminal, common collector configuration is approximately equal to the unity. We will discuss it in later in case of AC analysis, when we will discuss the AC analysis of the transistor. So that this is all about the connection of the BJT. Now, since there are two junctions, one junction is in between the collector and base and second one junction is in between the emitter and base. There are two junctions. So that there are four possible biasing of the junctions. Now, if emitter base junction is forward bias and collector base junction is reverse bias, this is called active region, and in this active region we can use the transistor as an amplification or as an amplifier. Now, if both the junctions are forward bias, the transistor works in saturation region. We can use in saturation region transistor as an closed switch or on switch. Now, if both the junctions are reverse bias, this is called cutoff region. This means transistor will works in cutoff region, and in this region we can use transistor as N off switch. Now, fourth connection may be written as, this is called fourth connection. Fourth connection is like this. This is the reverse bias and this is the forward bias. In this condition it is called inverted. It is called inverted, yani opposite of the transistor working, and it is does not exist. Does not exist. Why it does not exist? Because if we reverse bias the emitter base junction, what will be here? The emitter layer will try to collect the majority charge carrier, and if we bias the collector base junction forward bias, then collector will try to emit the majority charge carrier. This means this is the opposite function, so that this function is called inverted. Yani this function, this biasing or this connection of battery is not exist for bipolar junction transistor, because the function of these two layer interchanges, but the collector size is greater and emitter size is less than that of collector, so that it is not possible. As per the function, as per the role, we have already decided the size as well as doping of bipolar junction transistor. So, fourth one does not exist. Now, working of NPN transistor in active region basically. So, in active region the emitter base junction must be the forward bias, so that we have connected the negative plate of the battery with the emitter terminal. Since collector base junction must be the reverse bias, so that we have connected the collector terminal with the positive terminal of the battery as shown in the figure. Now, what will be here? The negative plate of this battery will repel the electrons of the N type layer towards the base. What will happen? The negative plate of this battery repels the electrons of the emitter towards the base. This will constitute the emitter current IE. Now majority carriers electrons are at the base layer. What will happen? Now, there are two ways to conduct. The first condition is that the few electrons will recombine with the majority carrier of base layer, that is with the holes. This is called the recombination current or base current. Suppose 100 electrons will be repels from the emitter to the base. Now, 2 electrons will recombine with the 2 holes of the base layer. This will call the base current or recombination current. Now, 98 electron, or you can say more than 98 electrons will be collected by the collector layer, and that will call the collector current IC, and IC is equal to the alpha times IE, and the alpha is called the current gain for common base configuration, because this connection is the common base connection. Why common base? Because here base is the ground, so that it is called common base connection, and the value of alpha is near about 1, that is it is near about 0.98 to 1, that is it is very close to 1, but never equal to the 1. Now, this is the conduction of the majority charge carrier. This means the collector current, that is output current due to the majority charge carriers, is equal to the alpha IE. Now, if we apply the KCL here, what will happen here? That IE equal to IC plus IB, because IE is the outgoing current and IB and IC, this is the, because electrons are going inside the emitter layer, so that the direction of the emitter current is this, in this direction. direction of the emitter current is outward direction, and the base current and the collector current are in this direction. So that emitter current is equal to the sum of the collector current and base current. Now, what about the conduction of minority carrier? I have already discussed this point. Now, what about the conduction of minority carrier here? This is the conduction of minority carrier, because since to observe the conduction of minority carrier, we have to open circuit the emitter terminal. Why emitter terminal has to be open circuited? Because in presence of majority carrier, we cannot identify the conduction of minority carrier, because the number of majority carrier are more than that of minority carrier. So, to observe the conduction of minority carrier, we have to close the supply of the majority carrier, so that we have open circuited here. Now, what will be happen here? It is like that, if we will design a circuit like this, this is the collector layer and this is the emitter layer, and we have open circuited, and this is the reverse bias. Okay, guys. Now, this is open circuited OC. Now, what will here? This is the reverse bias. Now, this is the N type, this is the P type, NPN. Now, few minority electrons of P type base will be conduct in this direction, and few holes minority carrier of collector will conduct in this direction. Due to this, a current will exist in this loop, yani clockwise, anti-clockwise loop in this direction, and this current is called ICBO. This current is called ICBO, that is collector to base current when emitter terminal is open, and this current is also known as leakage current, and this current is due to the thermally generated minority carrier. Now, the total output current is equal to IC is equal to IC majority plus IC minority. Now, IC majority is nothing, this is the alpha I already we have discussed, and IC minority is the ICBO. So, this is the total output current here. Now, earlier we have discussed that it is the bipolar junction transistor, and now I am going to discuss the another facts about the bipolar junction transistor is that the bipolar junction transistor is the current controlled device. Why it is current controlled device? Because the output current IC is the function of input current IE, because IE is the input current and IC is the output current. So, this means the IC will be controlled by the input current IE, that is why it is called the current controlled device. Now, already we have discussed. If you guys want to discuss the PNP transistor, we can easily discuss the PNP transistor. The same will be there, but the connection of the battery will be reverse and layer will be reverse. In place of electrons, the majority carrier will be the holes, and in the same way there will be the equation, that is IC equal to alpha IE plus ICBO. Now, common base configuration circuit diagram. Now, this is the common base configuration. We guys can see that base is grounded. This is the circuital label, and there are 2 voltmeters and 2 milliampere meters are connected, because this milliampere meter is connected to measure the input current IE, and this will measure the output current IC, and this voltmeter will measure the voltage in between emitter and base, and this voltmeter will be measure the voltage in between collector and base. Now, what will be here? This is like that. This is the input characteristics. So, before discussing the input characteristics, I want to discuss the current gain of common base configuration, that is equal to the alpha. There are two types of alpha, you can say current gain alpha DC and alpha AC. Alpha DC is equal to the output current upon input current. Here output current is the collector current and input current is the emitter current, that is why IC upon IE, that is alpha DC is equal to IC upon IE. On the other hand, alpha AC is equal to change in collector current and change in output current upon the change in input current, that is this is called the delta IC upon delta IE, but VCB should be constant. Now, I am going to discuss the input and output characteristics of common base configuration. So, to draw the input and output characteristics of common base configuration, we need to design the circuit. This is the circuit diagram, experimental circuit diagram, and we have connected 4 meters already I have discussed. Now, I will draw the input characteristic. The input characteristics in between input current and versus input voltage, that is IE versus VBE. This is the circuit diagram, and we have draw the 3 curves for various output voltages, VCB equal to 1 volt, VCB equal to 10 volt, VCB equal to 20 volt. Now, the graph of the VCB, is graph of the VCB having 1 volt is have least slope. On the other hand, if we are increasing the VCB values, then the slope of the graph also increases. Why it is like that? So, first of all, we need to discuss the input resistance, that is what is input resistance? Input resistance is nothing. If we are taking the 2 points, here, then what will be here? This is the change in voltage, and if we will draw the perpendicular to the y axis, then it will be the change in current. This means input resistance is equal change in input voltage upon change in input current at VCBs must be constant. So, this is called input resistance. Now, this means the slope, if slope of the graph will increase, then what will happen? The input resistances will be decreased and the current will increases rapidly. Why it is like that? Why it is like that? If we are increasing the VCB, then slope of the graph also increases, that is input resistance decreases. It is because of the, if we are increasing the output voltage, that is VCB, then what will happen? The collector layer will collect the more number of majority charge carriers. This means the collector current will increase. Since the collector current will increase, this means IE input current must be increased. If input current must be increased, this means the slope of the graph, this means input resistance must be decreased. Since input resistance must be decreased, so that the graph of the slope increases. So, that is why this is the reason to slope of the graph increases if VCB increases. Now, output characteristics. The output characteristics, for output characteristics, the graph will be in between the collector current, that is output current, versus collector voltage VCB. At IE must be constant. Then this graph is for I equal to 1 milliampere. This graph is for 2 milliampere, 3 milliampere, 4 milliampere, 5 milliampere, 6 milliampere, and 7 milliampere, so on. And here at the left side, the VCB voltage is negative to represent the saturation region, because for saturation region both the junctions must be the in forward bias. So, to bring the collector base junction forward bias, obviously we have to take the collector voltage negative. So, the collector voltage at the left side is negative. So, this region is called saturation region, and this region is called cutoff region, and this region is called, in between this and this region is called the active region. Now, explanation of these 3 regions. Explanation of these 3 regions for active region. If collector base junction is in reverse bias and emitter base junction is in forward bias, transistor works is in active region, and in active region we can use this transistor as an amplifier circuit. This means for active region VBE must be 0.7 volt if it is made up of silicon material, and VCE must be greater than 0.2 volt. And now saturation region, if both the junctions are in forward bias, transistor works in saturation region, and in this region transistor can be used as an on switch. And for transistor must be, if transistor is in saturation region, then VCE should be equal to the 0.2 volt, and VBE increases because the input current increases, so that slightly VBE also increases, that is it is equal to the 0.8 volt. On the other hand, for cutoff region both the junctions are in cutoff region, that is in reverse bias, so that the it is used as an off switch, and in for off switch the emitter current is equal to 0 and collector current is equal to the leakage current. So that this is all about the explanation of the common base configuration. So guys, overall the conclusion is that we can use transistor as a amplifier, as an amplifier as well as an switch. In active region transistor is used as an amplifier, and in cutoff and saturation region we can use as an switch. In cutoff region transistor is as an off switch, and in saturation region transistor is as an on switch. Okay guys, already it is the working of transistor completed, and in this lecture, in the next lecture I will discuss the another configuration of transistor, that is common emitter configuration. Okay guys, see you again.